Today, review the final exam. We'll review Chapter 9, 10, 11. Chapter 9, Formulas. Z-test for comparing two means from independent populations. This is for the standard deviation are given. Population standard deviation sigma 1, sigma 2 given. T-test for comparing two means from independent populations. When population standard deviation unknown, and give the sample standard deviation S1, S2, and use this t-test formula. Degree of freedom is smaller of N1 minus 1 and N2 minus 1. The third one is a t-test for comparing two means from dependent samples. So we will find out the difference of the two samples. This is a t-test formulas. Find the average summation of difference divided by n, which is the mean of difference. Find out the standard deviation of the difference, SD. Use this formula and plug into this t-test formula. The next, for proportion, comparing two proportion, use a z-test. This is the formula. And the P proportion, mean of proportion is the two sample, x1 plus x2 divided by total n1 plus n2. Q bar is 1 minus P bar. Next, F test for comparing two variance and larger variance is placed in the numerator. It's variance S1 squared, sample variance, over variance S2, smaller one variance on the denominator. And this is the F test. First question. This is for Chapter 9. The average year earnings of male college graduate with at least a bachelor degrees are $58,500 for men age 25 to 34. The average yearly earnings of the female college graduates with the same qualifications, which is age from 25 to 34, are $49,339. One is for male, one is a female. That's the population mean. Based on this result, on the result below, this is sample. Can it be concluded that there is a difference in mean earnings between the male and the female college graduates? Between the two mean. Mean 1, N1 is 40. N2 female, 35 females. Sample mean for the male is X1 bar is 59235. X2 bar, which is a female, sample mean is 52487. And the population standard deviation given. So sigma 1 is equal 8945. Sigma 2 is 110, 125. 1 alpha is 0.01. So this is given. 5 steps for hypothesis testing. Step 1, state the hypothesis. Null hypothesis is the population mean 1 equal population mean 2. The alternate hypothesis is mean 1 not equal mean 2. And this is the one to test. Can you conclude there's a difference? So this H1 is the claim. Identify the claim. Step 2, find the critical value for two-tailed test from T-table on the last row. For the degree of freedom is infinite. That is for Z. and alpha equals 0.01. Critical value is alpha equals 0.01, two-tail test. So here, two tails. Alpha equals 0.01, two tails, which is this, the rightmost column, go down to the last row. Last row is Z, degree of freedom. It's infinite. Intersection is 2.576. And since two tail, so the critical values is a positive, negative 2.576. Alpha is 0.05 divided by 2, so each tail is 0.05. 0.05 is left tail and the right tail, and those two numbers are critical values. And find out the test value, compute the test value. Z equal x1 bar, which is 59235, minus x2 bar, sample mean 52487, minus mu1 minus mu2, population mean from hypothesis. They are equal. So subtraction is 0. Divided by square root of standard deviation sigma 1 is 8945 squared over n1, it's 40, plus sigma 2, 10125 squared over n2, it's 35. And use calculator, figure out, round it to 3 decimal digits, is 3.039. And 3.039 is greater than 2.576. So it's to the right of critical value. So this test value 3.039 is falling in the critical region. In critical region is suppose H1. Between critical number is suppose H0. So this side is reject. Make decision. Reject null hypothesis H0. So we will reject null hypothesis. Then summarize the results, step 5. And we have put down results with the claim. Since the claim is H1, so this reject H0 is support H1. So we will say there is sufficient evidence to conclude that there is a difference in mean earnings between male and female college graduates. Second question. The mean for the number of weeks 15 New York Times hard copy fiction books spent on the bestseller list is 22 weeks. The standard deviation is 6.17 weeks. And the mean for the number of weeks 15 New York Times hard copy nonfiction book spent on the bestseller list is 28 weeks. And the standard deviation is 13.2 weeks. Both are sample mean for fiction. So X1 bar fiction is 22 weeks. X2 bar for nonfiction is 28 weeks. Sample standard deviation S1 is 6.17 weeks. S2 sample standard deviation is 13.2 weeks. Alpha equals 0.05. And N1 it's 15. Because here's a 15 New York Times hard copy fiction books. So total 15 books. Another one, second sample also 15 hard copy non-fiction books. So N2 also 15. Can we conclude that the mean for the number of weeks of non-fiction books spent on the bestseller list is greater than that of fiction book? So non-fiction we assume is mu2, and one population mean for non-fiction is mu2 is greater than the fiction, which is the population mean mu1, and this is the claim is H1, and hypothesis H0. Null hypothesis is population mean 1 equal mean 2. Second, mu2 is non-fiction, is greater than fiction, mean 2, mean 1. Step 2, find the critical value. Since this is greater than mean 1 less than mean 2, this less than symbol point to the left. So this is left tail test. Point to the left. And alpha is 0.05. Totally go to the left tail. Given to the left tail. Degree of freedom is the two sample N1 minus 1 or N2 minus 1, the smaller one. Since N1 is 15, minus 1 is 14, N2 minus 1, N2 also 15, minus 1 also 14. The smaller one is 14. So from T table, the row with the degree of freedom 14 and one tail test. So alpha equal 0.05, one tail, which is one tail, 0.05, and go down to degree of freedom, it's 14 here, 14. This go down. Go down to the 14. Intersection is 1.761. Since it's left tail test, so the value is a negative. So the critical value is a negative 1.761 on the left side. It's negative. On the right side is positive. Step 3, compute the test value. Use T. Because S1, S2, sample standard deviation is given. Population standard deviation is unknown. So use T. T equal X1 bar. Sample mean is 22 weeks minus X2 bar. Sample mean is 28 minus mu1. Population mean difference is 0. According to the null hypothesis equal. Subtraction is 0. Over square root. S1 is 6.17 square over N1 15 plus S2 is 13.2 square over 15. Take square root and use calculator. Figure out. Round it to the 3 decimal digits. Get negative 1.595. And this is a T distribution, normal distribution curve. Negative 1.595 is greater than negative 1.761. So we'll fall to the right of critical value. So to the right of critical value on this region is suppose H0. So it's a fail to reject H0. So it's not support the claim. The claim is H1. So this conclusion, make the decision fail to reject null hypothesis. Step 5. There is not sufficient sample evidence to conclude that the mean for the number of weeks of nonfiction book spent on the bestseller list is greater than that of the fiction books, which is this statement. Mean this from the question. Question 3. A random sample of 6 music students. 1, 2, 3, 4, 5, 6 music students. Students A, B, C, D, E, F. Played a short song, and the number of mistakes in music each student made was recorded. After they practiced the song 5 times, the number of mistakes each student made was recorded. The data are shown. Alpha equals 0.05. Can it be concluded that there was a decrease in the mean number of mistakes? So here the data recorded have 6 students. Mistakes before practice, like student A is have 10 mistakes. After practice, the mistake after practice is x2 is 4 mistakes, and etc. Like a student F, before practice mistakes is 8 mistakes, x1, x2. After practice, x2 is 9 mistakes. And this is a dependent because each one is dependent. They are dependent. So we will use difference. Step 1, state the hypothesis and identify the claim. If practicing the song is effective, the mistakes before practicing should be greater than the mistakes after, which is decreased. So the difference before is greater than after. So x1 minus x2, the difference is a positive because before is more mistakes than after. So the difference is a positive. The average we call mean of the difference. Average of the difference, one test whether it is greater than 0 or not. Null hypothesis is average of the difference is 0. So this is the claim. Test for the mean is greater than 0 is the claim. Mean of the difference. Then we find the critical value. Find the critical value. The degree of freedom is n minus 1. Have n is 6. 6 minus 1 is 5. And this is greater than 0. So it's a right tail test. The point to the right. So it's a right tail test. And you go from T table. The row with degree of freedom 5. One tail. So 0.05, one tail. One tail here, 0.05. Then go down to degree of freedom is 5. Go 5. And one tail, alpha, 0.05. Get 2.015. 2.015. And since this is greater than 0, so it's a positive critical value, point to the right on the right tail. So critical value is positive 2.015. Then we need to create this table. First of all, mistakes. Total 6. X1 is 10, 6, 8, 8, 13, 8. 10, 6, 8, 8, 13, 8. Before practice, mistakes. After practice, 4, 2, 2, 7, 8, 9. 4, 2, 2, 7, 8, 9. X1 and X2. Because we are going to use the T formula and find difference. So we need to figure out, because we are going to use T formula. T formula, we need to figure out the average of the difference and the standard deviation of the difference, SD, D bar. We need to find D bar. And what is the D bar? D bar is the summation of difference divided by N. So compute the test value, make and complete a table. B, find the difference of X1 and X2 and place the result in column D equal X1 minus X2, which is find the D equal X1 minus X2. 10 minus 4, 6. 6 minus 2, 4. 8 minus 2, 6. 8 minus 7, 1. 13 minus 8, 5. 8 minus 9, negative 1. Find out summation of the D. So 6 add 4, add 6, add 1, add 5, add negative 1 equal 21. Then figure out the D average. So find the mean of the difference. So the D bar equals summation of D over N. Summation of difference is 21. N is 6 divided the mean of difference, D bar, equals 3.5. Then we need to find out the standard deviation of the difference. In this, we need summation of D square. So find in this formula, we need summation of D square. So you on the table, find D square. Like 6 square, 36. 4 square, 16. 6 square, 36. 1 square is 1. 5 square is 25. Negative 1 square is 1. Then you summation, you add together. 36 add 16 add 36 add 1 add 25 add 1. Summation of D squared is 115. Then plug into the standard deviation formula. This is the standard deviation of difference is equal square root of N. N is 6 times summation of D squared is 115 minus summation of difference is 21 and square over N is 6 times 6 minus 1. Then figure out is the square root of 8.3. And then plug in, find out test values. T equals D bar. D bar is 3.5 minus mean of D. Population mean of difference is according to the hypothesis. Mean of D equal 0. So it's 0 over standard deviation is square root of 8.3. O divided by square root of N. N is 6. And use calculator and round it to 3 decimal digits. You will get 2.976. Round up. This is the test value. Then look at the graph. This is the T curve, T distribution curve. And this is a critical value is 2.015 from step 2. Alpha is 0.05 totally given to the right tail. From step 2, we find out critical value is 2.015. From step 3, we find out test value is 2.976, which is greater than 2.015. So test value 2.976 is fall into the right, fall into in the critical region. So this reject H0, support H1. And the H1 is our claim. So we will say there is sufficient sample evidence to support the claim that the mean number of mistakes has decreased. That is the question. Can you conclude that there was a decrease in the mean number of mistakes? Then question 4. A study found a slightly lower percentage of lay teachers in religious secondary schools than in elementary schools. A random sample of 200 elementary school and so sample size elementary 200 and 200 secondary school teachers from religious schools. So secondary school 200, N is 200. In a large diocese found the following. This is the table. For elementary school lay teachers, X is 49. And for secondary school is 62. At alpha equals 0.02 level of significance, is there sufficient evidence to conclude a difference in proportion? In proportion, we always use z-test in proportion. So from this given table, we find out x1 is 49, n1 is 200, x2 is 62, n2 is 200, and alpha equals 0.02. And state the hypothesis and identify claim. Null hypothesis H0 is P1 equal P2. Population are equal. Alternate hypothesis is not equal because one tests whether have a difference. So proportion, population proportion, P1 not equal P2, and identify it is the claim. Step 2, find out the critical values. And since H1 is not equal, so this is a two-tailed test. And if you draw a Z curve, normal curve, alpha 0.02 divided by 2, so right tail is 0.01, left tail 0.01. Critical values, so because this is Z, so we will use from T-table, two-tail test, 0.02 here. We'll go down to the last row, the bottom of the T-table, alpha equal 0.02, column down to the last row, which is Z. Degree of freedom is infinite for the Z. So critical value is here, 2.326. Since it is a two-tail, so left tail and right tail. So there's two of it, so positive and the negative. 2.326 right tail and the left tail, positive and the negative. Right tail and the left tail. And step 3, compute the test value. Test value, we will use Z test formula for proportion. We need to figure out P1 hat, P2 hat. Also need to figure out average of P, mean of P. So it's P bar and the Q bar. So compute P1 hat, P2 hat, P bar, Q bar, and then substitute in the formula. Let P1 hat be the sample proportion of lay teachers in elementary school. This is P1 hat. Let P2 hat be the sample proportion of lay teachers in religious secondary school. So P1 hat is X1 over N1, 49 over 200. And the P2 hat is X2, N2, so it's 62 over 200. And the average proportion is the two sample for the layout is 49. X1 is 49 plus X2 is 62 divided by N1 is 200, add N2 200. So get P bar average is 111 over 400. Q bar is 1 minus P bar is 1 minus 111 over 400. So the 400 minus 111 get 289 over 400. And plug into this Z test formula, which is P1 hat. P1 hat is 49 over 200 minus P2 hat, 62 over 200 minus P1 minus P2. Since the null hypothesis is equal, so subtraction is 0. Square root of P bar is 111 over 400 times Q bar is 289 over 400. Put in the parentheses 1 over N1, 200 plus 1 over 200. Use calculator. Figure out is rounded to 3 decimal digits. Round up. So it's a negative 1.457. Negative 1.457 negative. So compare with the critical value negative 1. Negative is critical value is negative 2.326. Is negative 1.457 is greater than negative 2.326. So negative test value negative 1.457 is to the right of critical value negative 2.326. So this test value is falling non-rejection region, non-critical region. So this sample evidence is support H0. We fail to reject the null hypothesis. So then we conclusion we have state address with the claim. The claim is H1. So therefore we say there's not sufficient evidence to support claim. That claim is what? There is sufficient evidence to conclude a difference in proportion. So here that there is a difference in the proportion between the elementary school and the religious secondary school for proportion. Now question 5 for variance. 2 large home improvement stores advertise that they sell their pen at the same average price per gallon. A random sample of 25 cans, so N1 is 25, from store Y had a standard deviation. So S1 is 5.21. And the store Z has standard deviation 4.08. So standard S2 standard deviation is 4.08. And on a random sample of 20 cans, so N2 is 20. Alpha is 0.10. Can we conclude that variances are different? Variances. So here gives standard deviation S1. S squared is a variance. Then we first step is hypothesis. Null hypothesis is a population variance equal, and null alternate hypothesis difference. Variance, population variance are different, so it's not equal. This is the claim. Step 2, find the critical value. Since the test here is not equal, it's going to be two-tailed test. Two-tailed test for the chi-square. For f-test, this is use f-test. Two-tailed test. Alpha equals 0.10. We will use f-table. F-table, we have two. One is a 0.05 table. The other one is 0.025 table for f-table. So since two-tail, we need to 0.10 divided by 2 get 0.05. And we'll use 0.05 f-table. Degree of freedom for the numerator. The larger one put on numerator. The larger variance put on the numerator. The standard is 5.21 is greater than 4.08. So S1, N1 for numerator. So degree of freedom for numerator is 25 minus 1, which is 24. And the degree of freedom of denominator is N2, the smaller one. S2, S is the smaller one. That number, N is 20. Put on the denominator. So that's degree of freedom of denominator is 20 minus 1 is 19. And then we will use f-table with 0.05. So here has the f-table, 0.05 table. The other side is f-table, f-distribution table, 0.025. So here we will use 0.05. Degree of freedom, 24 for numerator, denominator, 19. Degree of freedom for numerator is 24. Degree of freedom denominator is 19 here. 19. Numerator 24 here. Intersection. Their intersection. 24 intersection. Get this number 2.11. That's F critical value. F value. Get 2.11. Then use f-test. Compute for the test value. The larger of the two variance is placed in the numerator. So f equals, the larger one is 5.21, standard deviation square is a variance, over smaller one, 4.08, standard deviation square is a variance. The ratio divided, get 1.631. Then this f-test, f-curve, one is a two-tail, 0.10 divided by 2. So right tail, this area is 0.05. Left tail, this area is 0.05. and we use the right side. Get critical value is 2.11, the right one, right number. And the test value f test equal 1.631. 1.631 is less than 2.11, so it's to the left of critical value. So that's test value is falling, suppose H is 0, a non-critical region. So this one is a fail to reject null hypothesis. And the claim is with H1. So there is not sufficient evidence to support the claim that the variants are different. And that's chapter 9. Question 1 through question 5, chapter 9. Chapter 10, we will find out the correlation and the regression. And the linear correlation coefficient formula R equal this. And t-test for correlation coefficient R, t-test formula. Regression line formula, B0, y-intercept, B1 is a slope formula. And the standard error of the estimate formula, we'll use those formulas. Question 6. The director of an alumni association for a small college wants to determine whether there is any type of relationship between the amount of an alumnus contribution in dollars and the number of years the alumnus has been out of school. Compute the value of the linear correlation coefficient for the data obtained in the study. This is the data, and make a conclusion. So because we want to figure out correlation coefficient, formula is R, this R equal. So we need to figure out summation of x times y and figure out summation of x, summation of y. Also have to figure out summation of x squared and summation of y squared. We need those data. And so we have to create a table. Make a table. Step 2, find the values of x, y, x squared, y squared. Then on this table, now here, alumni totally how many? 6. Here has a 6. From this table you can see 1, 2, 3, 4, 5, 6 alumni. A, B, C, D, E, F. 6 alumnus. And X is how many years graduate from the college. Alumnus A graduate 1 year. Alumnus B graduate 5 years. Alumnus F graduate from college for 6 years. This is from the given data 1, 5, 3, 10, 7, 6. Put on S column 1, 5, 3, 10, 7, 6. Contribution is how many dollars don't contribute to the college. So it's from this contribution Y. It's 500, 100, 350, 75, 80. So put on this Y column 500, 100, 350, 75, and 80. Then we need to figure out summation of x because of formula, R formula. This R formula needs to figure out summation x. So 1 add 5, add 3, add 10, add 7, add 6, get 32, summation of x. And we will use summation of y. So 500 add 100, add 300, add 50, add 75, add 80 is 1105. That's the summation of y. And in formula, we need summation of x times y. So x times y. 1 times 500, 500. 5 times 100, 500. 3 times 300, 900, and etc. 6 times 80, 480. Add those numbers together, we'll get summation xy. It's 3,405. And in the formula, also need to figure out x squared. So x column square, 1 square is 1, 5 square, 25, 3 square, 9, and etc. 6 square is 36. And we need to figure out summation of x squared. So add those together. 1 add 25, add 9, 100, add 49, add 36, total 220. And also need to find out summation of y squared. So y 500 squared is 250,000. 100 square, 300 square, 50 square, 2500, 75 square, 80 square. Add those together, get summation of y squared. Plug those numbers in this R formula. Now, n is 6.